Hey everyone, in this video we're going to learn how to write the equation of a quadratic function in vertex form. Our first example states the transformations performed to the parent function y equals x squared to get the quadratic function graph below. Use the transformations to write the function in vertex form. So we've done this before. We've been given a graph of a transformed function and asked to write the equation. In order to do that, we had to identify the parent function, identify the transformations. We found it easiest to look scaling followed by translation, and then apply the scaling and translation to the parent function to create the equation. In this case, it's easier because the parent function is always going to be y equals x squared. And when we manipulate to y equals form, that's vertex form. So looking at our first graph, first thing we want to do is see if there's a scale factor. And the way we're going to do that is to treat the vertex as the origin. So this point is 0, 0. So if I plot the points from the parent function, if this is 0, 0, then I have 1, 1, then I have 2, 4, I have negative 1, 1, negative 2, 4. So we see that the points that I plotted all aligned with the graph that we were given. That means there is no scale factor. So then there is only a translation. So how was the vertex at the origin translated to be the vertex at 3, 1? So it was moved right 3 and up 1, which is a translation of 3, 1. Applying this translation to the parent function, y equals x squared, we get y minus 1 equals x minus 3 squared. As a reminder, if we're adding 3 to x, then in our equation, we subtract 3. Adding 1 to y, we subtract 1. So now we get y equals x minus 3 squared plus 1. And there we have our equation in vertex form. So parent function, transformations, apply the transformations to the parent function, so that we can write the function in vertex form. So our next example, directions just state write the equation of each parabola in vertex form. So our parent function is y equals x squared. So first thing we need to look at is a scale factor. So we want to treat the vertex as the origin. So this is 0, 0. So if I graph the parent function, if this is 0, 0, then I have 1, 1, negative 1, 1, and I can see that there is a scaling. Looks to be like a reflection because the graph is opening the other direction. So what scale factor can I apply that would take the point 1, 1 up here and match it to the point here, which if, again, this is the origin, is the point 1, negative 1. So 1, 1 to 1, negative 1. So that would be a scale factor of 1, negative 1, which indicates we have a reflection over the x-axis, which does look to be the case. Just confirming this point here is negative 1, 1. So it would become negative 1, negative 1. Perfect. Okay, then we're going to follow that up with a translation. So how was the vertex of the parent function translated to become the point negative 1, 4? So that was moved left 1 and up 4. So that's a translation of negative 1, positive 4. Okay, so first we're going to apply the scale factor to the parent function. So we're going to divide y by negative 1. Now at this point, we can multiply the negative 1 over, or we can leave it. It won't affect our answer. I'll leave it in this case. Now we're going to apply the translation. So if we're adding 4 to y, then we're subtracting 4 to y. Since y is in the numerator, y minus 4 is in the numerator. And then if we're subtracting 1 from x, we're adding 1 to x inside that parent function squared. So we want this in y equals form, so we'd have y minus 4 equals negative x plus 1 squared. So y equals negative x plus 1 squared plus 4. And there we have the equation of the given graph. Next up, same directions, new graph. So again, we'll start by treating the vertex as the origin, so 0, 0. So if this is 0, 0, then we'd have 1, 1, 2, 4, negative 1, 1, negative 2, 4. Okay, so we can see that those points don't align with the graph they gave us. So we have to figure out the scale factor. Well, the point on the graph right here, again, if this is 0, 0, this is the point 1, 2. 1, 1, 1, 2. So a scale factor of 1 to a vertical stretch by a factor of 2 looks to be correct. Let's just check. Again, 0, 0, this is 2, 4, so 2, 8. 5, 6, 7, 8 lines up perfectly. Okay, and then we're going to follow that up with a translation. So how was the vertex, which is normally at the origin, translated? It was moved left 5 and down 6. So translation of negative 5, negative 6. So we'll start by applying our scaling. So we're going to divide y by 2. And then we're going to add 6 to y all over 2 because y was in the numerator. And we're going to add 5 to x inside the parent function. So putting this in y equals form, we'd have y plus 6 equals 2 times x plus 5 squared. So y equals 2 times x plus 5 squared minus 6. So there we have our equation in vertex form. One more graphing example. So again, start by treating the vertex as the origin, 0, 0. So if that's 0, 0, 1, 1, negative 1, 1. Okay, so we need to figure out a scale factor that lines these points up with these. So we definitely have a reflection, so we're going to have a negative value somewhere in our scale factor. So let's see. A nice point here is that point there. And let's see. 1, 1, 2, 1, 2, 3, 4. I know we can't see it, it's off the graph, but that's 2, 4, so let's see. How would 2, 4 become 2, negative 2? So 2, 4, right, that's what I want to think of that point as. And we're treating this point as 2, negative 2. So that seems to me to be a scale factor of 1, negative 1/2. Now some of you might have looked at this and said, well, what if we took the point 1, 1, and then to get 2, negative 2, use a scale factor of 2, negative 2. That would be correct as well. And I can write that one out after. And then we're going to follow that with a translation. So we move the vertex that's normally at the origin, right 2, down 1. So 2, negative 1. So applying our scale factor, we have y divided by negative 1/2 equals x squared. And then applying our translation, we're adding 1 to y divided by negative 1/2. And subtracting 2 from x in our function. So putting in y equals form, we have y plus 1 equals negative 1/2 x minus 2 squared. So y equals negative 1/2 x minus 2 squared minus 1. Now, if you saw it differently, maybe you saw the scale factor to be 2, negative 2. And then follow that up with a translation of 2, negative 1. So what would the function look like? Okay, so we would divide y by negative 2, and we would divide x by 2, and then we're going to apply the translation, so that's going to be y plus 1 over negative 2, and then x minus 2 divided by 2 squared. So doing both steps at once, just in the interest of time here, we'd have negative 2 times x minus 2 over 2 squared minus 1. That would be another answer, which would also be correct. And again, this blue case is if you looked at 1, 1, compared it to 2, negative 2. Again, we're treating the vertex as the origin. So 1, 1 to 2, negative 2 would be a scale factor of 2, negative 2. Next up, find the value of a for which the graph of f of x equals a times the quantity x minus 1 squared plus 7 contains the point -1, 19. Okay, so we're missing that coefficient in vertex form, but they gave us a point on the graph. So the first thing that I'm going to do is plug -1 in for x. So f of -1 is equal to a times -1 minus 1 squared plus 7. Now what is f of -1? Since they gave us the point, the y value here, 19, that's the output for f of -1. So we can substitute 19 in for f of -1. Then we have a times -2 squared plus 7. So we can clean this up. This is going to be 19 equals, so -2 squared is 4, so 4a plus 7. Now at this point, we just have to solve. We can subtract 7 from both sides. So we get 12 equals 4a, and we can divide both sides by 4. So 3 equals a. So the value of a that we're solving for is 3. And if a is 3, then the point -1, 19 is going to be on the graph. Last question, determine the average rate of change of f of x equals -1 times x plus 2 quantity squared minus 11 on the interval -2 to 2. As a reminder, average rate of change is just a fancy way to say slope. And this interval, if we wrote it out as an inequality, is -2 is less than or equal to x, which is less than or equal to 2. Okay, so we need to find 2 points, one at x equals -2, one at x equals 2, and find the slope between those 2 points. In order to do that, we need y values. So I'll start by plugging in -2 to the function. So it's going to be -1 times -2 plus 2 squared minus 11. So that's going to be equal to -1 times 0 squared minus 11, which is equal to -11. Okay, so our first point is -2, -11. Next, we're going to plug in +2 into our function. So that's going to be -1 times 2 plus 2 squared minus 11. So that's equal to -4 squared minus 11. So it's going to be -16 minus 11. So f of 2 equals -27. So our point is 2, -27. Now, we have to find the slope between our 2 points. So the slope, which we use m, so we have -27 minus -11 over 2 minus -2. So that's -27 plus 11 over 2 plus 2, which is -16 over 4, which is -4. So the average rate of change is -4. Okay, so this video focused on writing the equation from a graph in vertex form, and then followed up with 2 extra questions. One where we're missing a value in that vertex form, but they gave us a point on the graph. And then the last question is an average rate of change question where the function was given to us in vertex form. So practice these types of questions, feel comfortable and confident with all of it before moving into the next video. Click the Amazon link down below for my algebra workbook so you can practice on your own. Give the video a like, and before you go, click that subscribe button so you can see more videos just like this. Thanks for watching.